sorry we got cut off in that last video, but essentially to wrap up that last one, it was what's the most efficient way of stacking? And if you look here, we have 23.34% of the base is not used, and here only 21.46% of the base is not used. So we are using more of the area, we are using more of the base when we stack with method A than when we stack with method B. There's more leftover room or more unused space with method B. So that kind of suggests that method A is a more efficient way of stacking these cans in the sense that it doesn't use up as much, or sorry, it uses more room and there's less wasted space. So that's about as far as we got yesterday. I wanted to show you guys just some wording on those questions so you guys can see those a little bit. So these pretty much just summarize what we just talked about, but essentially what are similarities? It says all variations have the same soda can radius, therefore the same base area of 1 and 12 cans. All variations in method A have the same base area in the box, same area, same percent of base not covered by cans. So again, those are just the things I highlighted on the sheets page. Some differences in the dimensions. Again, we talked about how if you're stacking different rows and columns, your dimensions will be different. And since the dimensions are different, that means that the areas of both boxes are different, as well as the percent of the bases covered between method A and method B. And last but not least, it says, what do you think these quantities suggest about the efficiency of the different stacking methods? For method A, we have less unused space. There's only 21.46% unused. Method B, however, has 23.34% unused. So method A is definitely the more economical or efficient way to stack the cans, and so you can see that from the data here. So let's move on to part B, which is going to look at some more information. Alright, so here's part B. I'll do a little bit of explaining to do the best that I can to get you guys on board with what we're talking about, and then I'll flip it over to the teacher's edition, I guess you could say. So you guys can see the answers with me and kind of write down some of these things in your notebook. So for arrangement X, if we read this new part together, it says, the beverage company is planning to put 20 cans in a box stacked in one layer. So before we were looking at 12 cans in a box, and now we're looking at 20. So we'll see if that makes a difference in what we do. It says they have asked you to do an analysis to determine the best way to arrange the cans in order to minimize wasted space and packing materials or packaging materials. It says the diagram below represents one arrangement proposed by the company. So just like we did in our last example, and we didn't necessarily have to calculate these things, our spreadsheet calculated it for us, but it calculated things like what was the area of one can, what is the area of, in the last example it was 12 cans, now it's going to be 20 cans. It calculated the area of the bottom of the box, so we'll be able to do that as well as it calculated the leftover space. So those are the things essentially I want to look at right now. I want to look at the dimensions of the box, I want to look at how much area the cans take up, I want to look at how much area the box actually has total, and then I want to subtract away the cans so we figure out how much is unused or left over afterwards. So let's first look at the area of, or the dimensions, so we can figure out the area of the box. So I just drew in, if you guys can see it right there, I just drew in one radius. So if I drew a radius for every single one of these, you guys could see that. But remember that the radius only goes halfway across the circle. And so if you look all the way across the circle, and I'll kind of do it in a different color so you guys can see the two radiuses butting up against each other. If I drew it all the way across the circle, you guys can see these purple ones and these red ones together would make what we call the diameter. And so the diameter is just two of the radii. So a radius here, 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 a radius here. So all of those are individual radii. And if you look from one edge of the box all the way to the other, you could count up how many radii there are across. So if there's 2 in each circle, there's 1, 2 here, there's 1, 2 here, there's 1, 2 here. There's 2 in each circle, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 circles going all the way across, and there are 2 radii in each circle. So if there's 10 circles, and there's 2 radii in each circle, that means the length of this arrangement is 20 times whatever the radius is. So keep that in mind. The length is 20 times the radius. I'm going to make a little note over here. Length equals 20 times the radius. All right, then what about the width? So let me erase this. The width is, if we look at a little radius there and a little radius there, and I'll do my alternating colors. You guys can see purple, red, purple, red. So if each one of these is a radius, then going up and down, since there are 2 circles and each one has 2 radii, there should be 4. So the width is 4 times the radius. So again, I'm making myself a little note over here that says the width is 4 times the radius. All right, so far so good. Now, using length and width, we know how to find the area of a rectangle. So the area of that square, or not in this case, sorry, it's a rectangle in this case, would be length times width. So that's 20r times 4r, which is 80r squared. And we can actually go ahead and plug in what we know r to be, because we know that r is 3.25. So it's 80 times 3.25 squared. And you can go ahead and put that into Desmos right now. So take a minute and put that into Desmos. So hopefully you were able to input 80r squared into Desmos and plug in 3.25 for r, since that's the radius we're using. And you guys can see I've come over here to the Teacher's Edition now, and I have some diagrams here. So I just wanted to show you guys really quick that I was just drawing it, but here's that arrangement X again for all the for the length. You can see all the different radii in there, and if you add them all up, there's 20 of them. And then for the width, you can see that there's 4 going up and down here. So if you add up all those 4 radii, you get 4r. So that's where we got length and width. We multiplied them together to find area again to get 80r squared. Hopefully in Desmos you plugged in 3.25 into that radius. So if you do 80 times 3.25 squared, Desmos should have told you that it's 845 centimeters squared. So the entire area of the box is 845. And when I say the entire area, I mean, I'll highlight this so we can see it all together. I mean this entire area, all right? So we haven't taken anything out yet. We are just looking at the area of the box. So now we're going into talking about this shaded region. So you guys can see down here from this other box that this is the shaded region I want to know. So I don't want to know everything filled in. I want to know what the box was, but then I want to take away all of these individual circles, all right? I want to subtract them out of the area from the box so that I can be left over with the shaded region behind it, or the unused space, you can say. So let's look at this sentence right here. It says the area of all 20 cans is 20 times pi times 3.25 squared. So I hope you recognize this little piece of it, because this little piece of it we looked at yesterday. This is the area of one of the circles. Pi times 3.25 squared is the area of one circle, and I'm multiplying it by 20 because there are 20 different cans in this arrangement. So 20 times the area of one of the cans is 663.7 centimeters squared. From there, we have unused space. We know how much it is total, so the entire box is 845. I know that the white circles would all add up to 663.7. Therefore, if I want to find the unused space in the box, which is the shaded region, I can subtract those. 845 minus 663.7 is 181.3 centimeters squared. So I think that gives us a pretty good idea of how much unused space is left in the box. And I'll give you guys a minute if you want to pause the video here, do so, and then write down some of this information into your Google Doc, and then we'll pick up with the next part of this with arrangement Y.